just think it's fun to
acceleration.
No, one chick already had a car crash video in her presentation today, so we just got double it.
Like it doesn't even have context for presentation.
Oh yeah.
It has like context for background.
I'm also looking for that video of Jake tackling me at the school.
That was me.
Are you tackling me?
I was, yeah.
Unless you got tackled more, I think it's funny too.
Yeah, because she was asking her friends.
Weekend was too bad. So just kind of backtrack. I have this side up just for the lecture side, so you can see what we're basing everything off of. So again, if you were here Friday, we're using these field notes, and again, this is on Canvas already. It's called the example traverse field notes. So again, if you don't see it on the lecture side or on the video on the lecture side, you just pull it up and just look at it there like that. But again, that's what we're using. So let me jump over to our state steps. So again, we're going to be working on that traverse data reduction and adjustment by compass rule. So currently we've done 1, did 2, and actually we did do 3. I just forgot to label it and I mislabeled it when we were working on it Friday. So I just backtrack and I'll just make that little correction real quick. And then the other thing that I caught myself, and I think one of you or 2 of you were here when I was doing it, that 90, that adjusted interior angle, I was correct. The second part of that, the first part, I transposed my numbers, so we'll go back and I'll show you guys where I did that. But again, so now we've got done with 1, AB, 2, AB, 3, 4, we're not doing. It's not necessary, but I will give you the formula for it. It's just your slope distance times the cosine of your zenith angle, or I'll show you that real quick. And then we're going to jump over to computing the azimuth of the traverse lines. So basically, what you're seeing on these field notes, these are the azimuths that they calculated, right? You see the notes, it says azimuth calculated from adjusted angles. So we're going to do the adjusted, we're going to calculate our azimuths from those adjusted angles and come up with these azimuths here. So let's go back to where we were on Friday. So again, like I said, this right here, I know everybody put a 91 there. That should be a 96. So change that to a 96. What happened was as I was writing these all out, I looked at the 71 on my notes and looked at the 96, and I just went 91. Suppose my numbers.
Oh, like way back.
Oh, way back before you.
Yeah.
Before we ever did.
Yeah. So I originally messed it up, and then I went down, and the next numbers that I had were correct with 96. So it's all 96 because if you use 91, you're going to be off by 5. You have it all up. 53, 55, 59, 56.
I just have a question. Are we supposed to do the homework 5 and 6? Like, it says it's due November 1st, is that the actual date?
No, I don't get enough time to change everything all at one time.
I was just making sure.
I'm kind of just running by the seat of my pants right now. I got lots on my plate, so I'm just trying to just keep it maintained.
That's 355, right?
No.
Oh, so you actually did it right on there?
Yes, that's correct. Right? So if you grab your calculator right now and add it all up, you would get this with these numbers.
Oh, with the 91 you're saying?
If you had 91, you would get 355, blah, blah. Make sense?
Yeah.
Okay. All right, so again, this part right here, the calculate, let me put a couple things down real quick. This part right here is actually our step 3. Calculate misclosure with step number 2. Yeah. And then calculate the AF, yeah, this part right here. Correct. This part right here was actually 3. Oh, what did you? This is just 3. Okay. That's just step 3. So we're at step 4 now, which is going to be the adjust or calculate the horizontal distance. But being that every single one of our field notes here, right? Kind of bring that up and zoom it in a little bit so you can look at the notes here, right? We're looking at the brackets, the columns here, are horizontal circle, right? It's when I have total station here, we're taking the measurements exterior, right? And then we have the zenith angle, right? And that is where the scope of the total station is at, right? Whether it's vertically, where it's tilted, how far up you're looking, how far down you're looking at the target. So for this example, everything is 90, right, or 270. If you take the cosine of 90 or 270, you get 0. You get 0. So so again, that wouldn't apply to calculate any slope distance or get horizontal distance, sorry, because you would get the exact same as your slope distance. But for just a quick note here on step 4, so if you needed to calculate, right, if necessary, your horizontal distance
Look at this.
is equal to the slope distance times the cosine. Cosine the angle or your whatever that is called. So again, let's say your total station is here. This is your horizontal distance, right? This is your slope distance. That angle here. So again, this angle here is minus your zenith here. So you think to yourself, well, how do I get that zenith? Well, that's already one of those measurements that is applied in the total station. So when you're looking at that little, when you're looking at the little faceplate on the total station, the two generic, so let's say you're looking at the faceplate, you'll see one that says B, right? And it'll give you some angle like 87, 32, 42. And then you'll get HR on that faceplate. Let's say it's 263, 34, 45. Oh, that's 5. That V is the zenith, right? And then that HR is the horizontal circle, this value here, okay? So I don't think the homework has horizontal portion to it. I think it's just the horizontal distances, should I say? That homework 5 or 4 was on it.
We don't need to answer the exam question now. The exam problem 10, well, exam 1, problem 10 has like a weird zenith question, and I was wondering if we could go over a similar example.
Yeah, we can go over that.
Okay.
Let's backtrack a second. Then let's go to the module here.
Because I had something to do with slope, distance, and for example, no, this is
The take-home exam.
The 10th question.
yeah,
Yeah.
the one that was absolutely cooked on. Well, like I'm cooked on everything, but like more so.
So this is at trigonometry leveling. I think we had an example that we did in class. Gosh, when was that? I don't know. 3 weeks ago, guys. Let's go back to the modules here. So if you go to the modules and you go to basic. So again, you guys are allowed to grab any of this for the exam, right? If you go to basic survey calculations. Make this big for you guys. It is like at the bottom of this thing. Right there. No, inverse. Right there. So again, same dilemma right here, right? You're given the HI, the HR, your elevation, your slope, your zenith. Here is the whole example, right? So it's a similar example. Again, you just provided switch numbers, right? Transpose the numbers, however you want to say it. Trying to help you guys out, trying to. It's just I know you guys have a lot more, a lot more classes, but
Could you go through that one?
go through it.
Yeah, for about, I don't know, 3 steps.
Okay. Which parts do you need me to go over?
Yeah.
Okay, so let's see. I think I went over it
Hi, Dad.
on the whiteboard here. The great thing about this is when I erase
At
it,
least I can read his handwriting.
let's see. You guys make me go down memory lane.
But man, I'm remembering it all. You two are having a mental breakdown next time. I'm just on.
No, I'm just cooking everything.
And I'm just making fun of the song crowd.
That's all 9:30.
That's all.
Partial latitude.
Sad if I had a mental breakdown. I'm just like cooked.
Maybe a better question.
Where is it pretty
Yeah, which,
No.
could you get back to
You're
that?
exhausted. Yeah.
Yeah, I'm trying to find that example that we
No,
did
not
together.
because I don't even have
Well,
it.
because you're quit.
No, I'm not.
But
quitting.
anyways, I'll just do it real quick.
Just kind of lean back.
Alright, so
Yeah, no.
let's zoom in.
Circle it.
and let's go over trigonometry level. Today's what? 20 something? 28? Yeah.
Why was he trying to do the integrals like?
So again, I'm gonna give everything, so we're gonna have a given, a required, and then we'll go with the solution here, right? So if I go, we have our given. The height of instrument, right, what you set up is 5 feet. The height of the rod, right, the prism that you are using is, oh, sorry, I got that, that's 547 for the gauge, so it's the other way around. $547, right? And your height of rod is 5 feet. Okay. The elevation angle is what they call it, or the zenith. Well, here's the zenith is 87 degrees. And then we have our slope distance of 510 and our elevation of 100 feet, right? So let's go elevation of A. Feet. All right. Slope distance 510.32. And then the zenith angle was 87 degrees, 0 minutes, 0 seconds. Correct? All right, hang on. Let me double check something. Okay, perfect. All right, so again, going back to what is required now. Let me just go down here. Need to find the elevation of B, right? So we have all our given information. We know what we got to do here. Now it's just applying the formulas. So our first formula is to find the elevation angle, and again, that's just a constant of 90 subtracted by that zenith angle. That zenith angle again is measured from your height of instrument, and from this point, is it below or above your horizon? Below, right? Because you're 87 degrees, so you're looking down, right? So if this is level to you, and this is 90 degrees to you. Your eyesights are down to that target, right? So again, first thing we'll just put down is solution. And the elevation angle is equal to, again, our 90 minus our CNF, which would be 87, so it's 3 degrees, right? So there's that. Then the next part is solve for the height difference on opposite side of the triangle, right? So again, we have just a constant formula, and that is the delta height is equal to the slope distance times the sine of our elevation. What was the horizontal distance formula again? I gave you guys. It's close, right? Pretty close. It's just cosine, right? That's all it is. It's just cosine, right? So again, we need to know the height delta of the rod is equal to the, again, slope distance times the sine of the elevation. To the slope distance times the sine of our elevation angle, right? Just going to be that 510, 32 times, make it a big S, sine of 3 degrees, right? Who's that? Who has that locked and loaded ready for give me an answer on that?
No.
I'll pick on Nick.
26.
Nick gives me everything. I'm going to pick on somebody else. So
You bring me
I
down.
don't know, could be.
bring it down or bring it up.
I can't see the givens.
The units?
Yeah.
Yeah.
Also screen down.
What do you mean? Okay.
Where we
It's the
started.
givens at the top.
Oh, the givens at the top, right?
Sorry, it's 26.
Well, here's our givens.
26.71.
0.71.
Yeah, I mean, if we want more, it's 70.
Or just give me 100, right?
70.
So again, that's just going to be the delta height is
No,
26.71.
it's not 0.35. It's
32.
gonna be like 0.5. Because it's 32 inches. Or is that 0.32 feet?
So if I go back to the formula,
What are you talking about?
Tommy
Oh,
gave
it's
you the correct value,
0.32.
right? Of 26.71 feet.
Yeah, 26.71 is what I thought, yeah.
Alright, that's 32, not 35.
So now we go, what we ultimately need is the elevation of B, right? So we're gonna go our elevation A plus our HI plus the delta height minus the HR. Alright, so let's go back through, and if you can see that, you can see it's 100 feet plus your givens, right? Oh, so your givens of 100 feet, your 5.7, what you solve for, and your other given is subtracted, your elevation is 127.18. Simple-ish? Okay-ish? So again, here's the other thing, guys. I know you guys are writing at a million miles an hour, but this is already there, right? It's already there. So don't get too stressed out if I go too fast, because I'm not gonna delete this. I'm not gonna be like, oh, they didn't keep up. I'm just gonna take it away now.
Yeah, that'd be really funny.
It's slowing down, but eventually.
As soon as I tell you guys that it's open note and it's open, everything, and then I just go on canvas and just be like, all right, just disable everything. And you guys are on.
Dude, do not give me ideas. If I was a
I would-
teacher, oh my god.
I already downloaded
That would be a little mean.
Came over
So-
to my students.
I wouldn't do that to you.
Oh.
So are we okay there? You jump back to traversing? Okay. Alright, so again, we figure it's not necessary, right, for the slope distance, using the slope distance for horizontal distances. Alright, we need to just compute the azimuths of the traverse lines, so essentially it reflects the notes on that side. Alright, so let's jump to that area.
What are you laughing?
It's all written down.
All the way down?
Yeah, pretty much.
Where's Nicholas at?
Okay, almost go.
Okay.
There we go.
Whoa. Do I like new songs?
You look like you just got laser eye surgery.
Alright, so number 5, step number 5. Step 5 again is to calculate line azimuths. And are we using any given information, or are we actually using some kind of specific information?
Specific.
We're using the adjusted information, right? From our previously computed angles, right? So that's what we have to use to figure out these azimuths. Again, from adjusted angles. Double underline that because that is of importance. Right? Or should I say? Okay. So looking at this, let me pull this up again. We set again that azimuth, right? That first read, we set it to 0. And then, so that is considered our north, correct? We're considering that to be our north. Right, so if I sketch it graphically here, we have north, east, south, west. Again, here is our point 1 here, right? And we are coming, we sat here, said this is north, that's 0, 0, 0. We're going 186, right? 186, 22, 23 on that first turn. Somewhere like that. And then we adjusted it all and it ended up being, what is it, 120, 186, 22, 24. We had to add a second, right? Because we didn't close by 4 seconds. You guys remember that part? We had to add a second to our angle. So again, that ended up being 186, 22, 24. That's the adjusted angle. So right off the bat, that's our azimuth, right? Because you come from that azimuth up there, turn to 2. So now we can figure out what our first azimuth is, which is going to be that 186.22 or 186.22, 24. So our azimuth from 1 to 2 equals to 186, 22, 24. Right? I'm going to do it just a little bit different because when I wrote these notes, I started going off my own tangent, and then I realized that I didn't really reflect the previous notes. But we're going to get to the same location, the same spot. Okay? So again, when we picked up where we sat here, all right, we got 186, 22, 24. Now we're picking up here and backsighting. We're sitting on 2 and we're backsighting 1. Is that the same azimuth? What's it going to be? 1 minus 180, right? So again, now we can reflect that back on the notes here, and we can say now that the azimuth from 2 to 3 is going to be equal to, and I'm just going to write it in this format for the whole thing. It's going to be 186, 22, 24. Actually, you guys, I'm just going to put degrees, minutes, seconds, so it's not so confusing. 186, 22, 24. Minus 180, right? And then the next portion is going to be, because we use the exterior angles to turn right, we're going to calculate the exterior angle based on the interior adjusted angle. So that's just going to be, we'll go 360, the constant of 360, minus our adjusted interior angle of 96 degrees. Put degrees there. 1 minute. 1 minute. 28 seconds. Right. Let me get this piece so it's not. And that's gonna be the azimuth from 2 to 3 of 270 degrees, 20 minutes.
Where did the 186 degrees come from? From the azimuth 1 to 2?
From the azimuth 1 to 2. That makes sense?
Oh, yeah.
Because again, you're physically set up on 2, right? You're backsighting 1.
Mhm.
That cannot be 186.22, right?
Yeah.
Graphically looking at it, if you're, if this was 1 here, then that corner was 2, and I'm 186 this way, I can't physically be 186 if I'm standing over there looking back this way, right? I physically can't be. I have to be what it is, 180 of it, right? Okay. So now, using that information, we can get to azimuths 3 to 4. And again, same thing. We go 270, 20 minutes, 56 seconds. Minus our 180. Okay. Then we're gonna go on this side. 360 minus our interior adjusted angle of 71, 12, 58 seconds. Okay. Now, if you guys do this real quick, let me grab a calculator and give me this value if you add it together.
$288.
And if you add it to this value, this result here, where you get,
That's just right.
yeah, this is just right here, right?
I think I got 379.133.
So is that inside the magnification of 360? So what we have to do, we got 379,
0.17.
we have to normalize it, right? Okay. So we need to normalize this part. Again, we can put that here. Get 19 degrees, 7 minutes, 58 seconds. But again, if I'm physically setting on 3, right? Physically set up on 3 here. I backsighted 2, and now I'm going to 4. Does it graphically represent what I'm doing? That azimuth that I just got. I'm physically set up at 3 right here, right? Just like the sketch, or just like the notes are showing. I backsighted to 2. I did the exterior angle calculations to get this azimuth 3 to 4. Does it physically or does it graphically represent my calculations? Right. Does that making sense of where I'm getting that 19.7? Yeah. All right, 2 more. Now, our azimuth from 4 to 1. Again, we're going to take our 19. But this time, what direction are we going? What was that, Ryan?
Adding 1.
Perfect. All right, so again, you're physically on 4. You're physically setting on 4. You got 1907.58 going from 3 to 4. Now you're backsighting 3. So what's that going to be? Your azimuth. Everybody? Anybody else said Ryan? Plus 180, right? Plus 180 because you're going graphically. It's to the southwest, right? Everybody on this one? Can't write it out. Graphically, yeah.
I've used it out of.
Go southwest, add 180, so
Yes, because again, so again, to sketch it,
Is that just to make the calculations easier? So you don't have to like normalize it?
I mean, you're gonna have to normalize it anyway. So you can see.
Why are you adding 360 minus the adjusted interior angle?
Because we're using our exterior angles that we calculated from here.
Yeah.
These guys. So we're using, yes, these guys, so these are the exterior angles, right? So using our adjusted interior angles, now we can go back to our exterior angles to calculate our azimuths. Because the whole field setup, when we did the field setup, was getting the exterior angles, right? So we have to go back to use the exterior angles to calculate our azimuths.
Okay.
Because what we didn't do from the first get-go was we didn't just start with interior azimuths the whole way. But because we use exterior azimuths, we have to do exterior angles, we have to calculate the azimuths that method. Okay? I know it's painful, doing this on purpose. So whenever you guys run a traverse and somebody wants to do exterior angles, you go, don't do that. But then again, you'll have a handy dandy big calculator thing called the data collector, and this whole thing does its work without having it right now. So again, we'll go our interior, the interior adjusted angle here. Did someone give me that value?
No, 447.3125.
Again, not within the magnificent, right? So again, we have to normalize this thing.
1845.
Perfect. Yeah, man. And again, does it make sense with our sketch, what we're doing, what we're physically actually going out in the field and doing? Right? If we're going 4 to 1, does it make sense that we're going in that direction? Right? The overall azimuth. So this is right. This way is north, right? I'm going that direction.
Yeah.
Right? Makes sense with the azimuth, right? All right, last one. Again, 1 to 2. Now, we take our azimuth at 4 to 1, 87 degrees, 18 minutes, 45 seconds. And again, you're physically set up on 1, right? You're backsiding to 4. So are you going to add or subtract 180? Hey, look at it, right? You're gonna look, now this is north again, right? That way's east, that way's west, right? And again, if you make another graphical sketch,
Really talking down, right?
Yeah, well, I need it. It's okay.
Damn. Treat
right?
yourself
if you,
better.
if you just break it down to that right there, right? You start 0, 90, right? It's the same thing. So this part you have to add or subtract if you're looking west. Add. You have to add.
add.
You have to add. You have to add.
How
You have to add.
did you say that? You messed me
Oh, my bad. My bad, Piggy Bear.
Not bad, Poopy Bear.
My bad.
Again, our adjusted interior angle was 80, 56 minutes, 21 seconds. And just to save you guys time, this will not be the magnetic, will not be inside the 360 magnification. So we have to again normalize this part as well. And if we do that, we should get the exact same azimuth we started with. Right? That should be our azimuth. As we started.
Why keep adding 360 if we're just gonna subtract it later? Again.
And you can do it any method you want. It's just one method. It's just to show you separate methods.
Okay.
That confusion.
I'll take that answer, I guess.
We okay?
We're good.
So now, step number 6, right? So step number 6, so again, we got step 5 out of the way. Step 6 is calculate unadjusted coordinates for each station. So again, this is gonna be that direct problem solution, okay? So we'll go back and I'll give you so you guys remember the formula for the Latin Latin departure formula? Off the top of your head, I guess, you know it.
Go last square plus go first square.
It's your slope distance times the cosine, right, of the azimuth. Right, or your departure is the slope distance times the sine of your azimuth, right? So we can get that. You guys should know this by heart by now.
That's good.
Yes. That's Orlando, idiot.
Not bad. God, yeah, dude.
So rude.
Oh, I guess I'm muted.
Step 6. All right, so again, step 6 is to calculate. I keep doing that. Calculate the unadjusted. Why do I keep saying unadjusted?
Because we did the adjustment for that.
I meant for coordinates. Sorry. Why do I keep saying unadjusted coordinates?
Because we haven't adjusted them yet.
Because we haven't adjusted them yet. That's a D. All right, for each station. So how many stations do we have? Right. So again, the lat is equal to the slope distance times the cosine of the departure equal to the slope distance, the sine of our azimuth. So the first thing that we're going to do, because we're not on a state plane or we're not in a coordinate system, we're just going to give arbitrary numbers, okay? And so our starting point is going to be 0.1. East and west, or north, sorry, not east, north and east. Going to be 5,000 5,000. Gonna give it a sign, 5,000, 5,000. Right? We can go 10,000, 10,000, 20,000, 20,000, right? You can just give it just arbitrary numbers to see if this works. So, looking at this information, right? We have our given information. If we look at the notes, we can go back down here, right? We have the slope distance, right, from 1 to 2, right? We have all the slope distances, and they're listed here on the sketch as well. Not there, but it is here. 84131, they just didn't write it here, but it is in their notes here. So again, you got your station, you got direct or reverse, the horizontal circle, the zenith, and your slope distance. Right? So we're given already the slope distance, we figured out the azimuth, so it's just how to plug those numbers in and add it, and then use it our 5,000, 5,000 starting point from there. So again, the latitude from 1 to 2 going to be equal to that slope distance of 1,024.78, right? And the cosine of our azimuth is 186.2 minutes, 4 seconds. And again, don't forget to put that in decimal degrees, right? Degrees, minutes, seconds, you got to convert that over to decimal degrees. Okay. You should get a negative 1,018.447. Okay. The departure. Equal to the same thing of the slope distance, 1,024.78. Sine, the exact same azimuth. And we'll get a negative 113.757. Okay. So then what is going to be the northing for point 2?
Where do you get the 1,024 from?
So when we took our measurements here on the field notes, we got a slope distance of 1,024.78. And if you look here, right, it's not shown here because this is to the azimuth. But if you scroll down further in the notes at the bottom, it's here.
Oh, okay.
You have it here. Slope distance there. Okay. So then how are we gonna write our northings for point 2 then? Right, so point 2, right? So the northing of 2 is going to be
3,981.553.
correct.
That's great.
Right. How do we get that?
Subtract it from that.
You subtract it from 5,000, right? And then 2 will be 4,086.243. Okay. So there's our coordinates for unadjusted point number 2. And this is point 2, 4 minutes. 0.3 here. Again, same formula. The latitude 2 to 3 is equal to the new slope distance. Go back up to the field notes. 1,064.08. Okay. So our slope distance 1,064.08 feet times the cosine of our newly solved azimuth or adjusted azimuth, 270. 20 minutes, 56 seconds. I get 6 point, oh, 6.197. Rewrite the formula for departure here. So again, the departure is the slope distance times the sine of your azimuth, which is 1,064.08 times the sine of the azimuth, that's 270 or 20 minutes, 56 seconds. And I get negative 1,064.6. So,
Fine. Let's see, for, point two, it says, N two. It's like 3,900.
Yep.
81, and then you have like 553, what's that?
point
Oh,
point
that's-
553. So the way you're gonna have to get used to this
That's
because
intuitive, I mean.
yeah, you're gonna have to get used to this. In real world, this number is written like that. You're gonna see that for the rest of your career as an engineer. Yeah. So you gotta get used to that. All right. So again, last piece here, and then we'll head out. The north of 3 is now this value that we just got. What do we apply it to? What coordinates are we gonna apply it to? The previous coordinates, right? The previous established coordinates. So it's gonna be at 3,981.553 plus our 6,479. That's gonna be 3,980.32. All right. And then the easting is going to be our, again, 4,886.243. Again, because it's a negative value here, we just subtract. It's going to be 1,064.6. Coordinate for that will be 3,822.183. In a little box like that. Okay, you guys understand that part, right? Okay, guys, we will calculate 3 and 4 on Wednesday. Or sorry, 4 and 1. What is it?
Those look like, it's on this, two thumbs up. Those look like the most additional ones, two thumbs up.
I don't know, just like. Yeah. I don't know how to.
Oh, do any work on mine?
I just need you to.
Dude, I have like 3 midterms I forgot I had.
I felt like
I have a math midterm, a physics midterm.
and this.
I have my honors midterm. I forgot I had honors. Dude, that's even a real class to me.
Honors.
Oh, dude, it's so fun
Tina.
to work.
You are adding 180 because you're looking basically like it's to the left of the, right?
No, not left, west.
West. West.
So again, so 0, what is 0?
0 north,
Right. What is 90?
east.
What is 180?
South.
What is 270?
West. So because it's you have to go this way.
From north.
So if it's somewhere over on this side, then obviously you're gonna have that one.
Right. Depending on where you are, right?
Oh.
Depending on the direction that you are
If
going.
I'm standing here, I can just draw my own coordinates.
Mhm.
I'm going over to Cornette.
Oh, right. Thank you.
No, I mean, I'm bad. That's why.
I'll give you a little feedback.
I'm changing it now.
I would just say the starting answer was incorrect and it got false.
Okay,
I was gonna let you know. That's the first thing that popped in my head.
so I think I changed this to.
Oh, here was the other thing too. This part right here. You're 3 minutes high, right?
Mhm, so I thought I,
You need to come down 3 minutes, right? You went 3 minutes up with everything. Or you went 30 seconds up with everything, sorry. You need to
okay,
go 30 seconds down with everything.
okay.
That too.
And then I didn't add the 180 on all these.
Right, but, well, I mean, you're still getting it, right? You're still doing that, but the other issue here, this is just the interior angle.
Mhm.
Oh, okay, you already got it, never mind.
Yeah, I just changed it
Yeah,
because I realized,
But you wanna use your azimuth,
okay,
okay.
okay.
Keep working
So I'm
on
gonna
that.
change these and then everything else.
Yeah, it should come out just fine.
Okay, thank you.
Just a quick question. The reason why there's no settings for 87, whatever, is because it's an azimuth, right?